G'day everyone, Peter Horsburgh is my name, and welcome to today's webinar titled Demystifying AI. I better introduce myself and we'll get into the content. I believe Ellie's just telling me that some people are still yet to arrive, but I like to respect people's time. And let's get into it. And so thank you for the people that have already arrived here and now. So let's talk about demystifying AI. And just by way of introduction before we get into it, my name is Peter Horsburgh. I'm the Managing Director here of Sologic Australasia. Ellie may come on and say, hey, Seven. That's me. That's my nickname. I'm known as Seven. I'm the author of the 5 Habits of an Extraordinary Reliability Engineer, and as some of the photos describe, I'm a pilot. I've been piloting aeroplanes here in Australia since 15. It's not my job, it's a hobby. It's just something I can't get out of my blood. And being a mechanical engineer, I have been working on with my sons what we call the racing red car, which is a Mazda RX-8. And those that know about these things, they're a rotary engine. And I've had one guy say, you're a reliability engineer. Why did you buy one of those things? And the answer is, I like a challenge. I've learnt lots about rotary engines. I have, and a lot about the car. And it's been a really good learning curve. Plus, it drives well too. Anyway, all right. So please stay to the end here, everyone. And the reason for that is we're going to organise you access to the Sorba University. We're going to organise you access to a Sorba Smart Data Engine virtual machine, i.e. the software, okay, that you're going to see today. And we're going to talk about today. We're going to offer a complimentary proof of concept. What is that? Basically, you give us some data and with where you've had a problem or a fault, or you want to optimize something, and we will see if it works, no charge. Okay, so complimentary. And of course, more importantly, a signed copy, not an electronic copy, but a real copy of the 5 Habits, my book, 5 Habits of an Extraordinary Reliability Engineer. So yeah, hang around for that. We'll announce that right at the end, and yeah, look forward to meeting and greeting the winner. So everyone, to start out with, what we want to do is a quick poll, and I'll just put Ellie on notice that she's ready to go. We've got 5 multiple choice questions here, and it's just popped up on my screen. And if you could just work through those questions for us, I'm going to have a look as well. What I wanted to do here today, you good people, is I wanted to talk about or work through and explain what AI is, okay? And then work through the common fears and misconceptions around AI and obviously the benefits. So we're trying to demystify the whole thing here today. And we've tailored this webinar for managers that may not be inside the AI space at the moment, but definitely looking to do so. As you'll see, it's becoming very popular. All right, so let's explain what this AI thing is. So what is it? Artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. Okay, so machines getting human-like behavior. All right. It all began with automating repetitive tasks, but now it's in the predictive maintenance space. That's how I came across it, being a reliability engineer, and in my corporate life, before I started writing books and doing what I'm doing now, I so wished I had Sorba, and I'll explain that as we go along with this webinar today. It's used in quality control, it's used in supply chain optimization, and it's also used in energy management. I'm going to give you some insights into that there today. All right, the core components of AI. Basically, there is 4 major components of AI. The first one, coloured in green, is machine learning. Essentially what that is the algorithms get better. They learn. So you start out with initial algorithm and they get better over time. So they get better at forecasting, and that happens on autopilot, hence the term machine learning. Deep learning is another type of component of AI, and what most people associated to what they call neural networks, i.e. they're trying to basically mimic the function of the brain as best as they can, okay? And it's able to handle vast amount of data. That's what deep learning is all about. Computer vision, as the name entails, is the machines learning to recognize objects predominantly, or features on objects, i.e. they can recognize the color, if it's got a crack, such and such. And the one that's getting a lot of airplay at the moment is natural language processing, i.e. a particular brand of NLP is ChatGPT. Rumor has it, it is the most popular app release yet when they released ChatGPT. Okay. In the natural language world, I have not used that in an industrial sense per se yet. I have used the machine learning part. So we're going to talk about that bit mainly today, hence it was coloured in green. Again, we are talking in an industrial sense. All right. How AI differs from traditional automation. Okay, traditional automation is all about pre-programmed instructions, whereas AI is adaptive learning, okay, in a real-time environment. So it can learn as new things start to happen, okay? It can adapt, it's adaptive learning. And that's what, you know, our little guy on the screen there, his name, we call him a sawbot, okay? So we obviously are from Sawber, and our machine learning is called sawbots, or bots for short, okay? And the application that we particularly use it for is advanced pattern recognition. He's really, really good. The sawbots are really, really good at recognizing difference in behavior of machines or processes. We'll get to that, okay? They're really good at recognizing difference in behavior, i.e. patterns of behavior in machines and or processes, okay? So talking about that, let's talk about the applications of AI in industry. These are some results from our customers. In the predictive maintenance space, they're a logistics company that we've been helping with, have seen a 30% reduction in downtime, 25% decrease in their maintenance costs, and a 15%, and as a result, a 15% increase in overall operational performance, given that they use a lot of automated plant to do what they do. Now, people ask us, can I have the slides from this webinar? We're going to do one better. We're actually going to give you a white paper, and there's some links in the white paper to these case studies on our website. So you've got something, if you're trying to justify this with your team, you've got some fuel for the fire, let's call it that, to help you along on that journey. They're included, some links are included in the white paper that will be dispatched as a part of this webinar. Okay, in the advanced process control side of things, so controlling a process, okay, using machine learning to do that on ammonium refrigeration plants, one of our customers has seen coefficients of performance, or better coefficients of performance, of up to about 15%. Okay, so, and that's with no capital investment. That's just the AI operating the machine, okay, as compared to a human. Now, I'm going to show you another slide, and this is one of my favorite slides because it shows how the AI is more consistent than a human. Okay, I'm human, obviously. Okay, I'm not an AI. And I know that I make mistakes. I see the world and it's based upon my experience. Okay. On the slide here at the moment is on the left-hand side of the screen, there is a production process, a beer production process being operated by an AI. And on the right hand of the screen, that is that same process that is being operated by a human. Okay. And I'd admit that I'd do something like this. And you can see there the consistency of the AI. Because it can recognize those subtle changes in behavior and it learns as it goes along, it learns the optimal set points to operate this process. And to put some numbers around that picture, as you can see there on the screen. So this is with sorber. So the process is filtering beer, which is awesome. The beer filtered is 8,000 hectolitres. The earth dosage, if you don't know about beer production, it's an additive that they add to help filter the beer. It's called earth or earth dosage. And the AI used 1,200 litres. Okay. On the right-hand side, if I could get you to focus on the right-hand side of the slide, on the wavy one, without sorber, the beer filtered by the human is 8,000 hectolitres, so the same amount. But in comparison, the earth dosage was 1,700 litres, i.e. 500 litres more of the earth dosage product that they used to achieve the same results. So that's an example of how AI and that machine learning and that constant adjustment and recognizing of patterns, that's a result that you can see, okay? A physical result of what happens, all right? So I'm going to continue on. Industry statistics and trends on this stuff, okay? So if you're looking at AI at your place, okay, the industrial sector has grown by over 60% in the last 5 years, and that's from McKinsey in 2023. We're now in 2024. A Deloitte survey of 83 manufacturing respondents think AI has made or will make a practical, visible impact. You can see there from some examples already where it has for one of our customers. Okay. Now the Deloitte survey went on to say that optimization and predictive technologies are the two most popular. Okay, the optimization and predictive technologies are the two most popular, and the reason why the little sawbot's there is that's what he's really good at. Okay, the two things that they're thinking is the most popular, the sawbots are really, really good at. All right, so I'm going to introduce sorber to you, and what does the name actually mean? It's all in the name, and sorber stands for Smart Operational Real-Time Big Data Analytics. Okay, that's what it means, or what's behind the name. Essentially, and the reason why the spanner or the wrench is on the screen is it's a set of tools. Okay, it's a set of tools for someone like me, being a reliability engineer, to use to achieve their outcomes of what they need to do faster and more efficient than what they would do themselves. Okay, I'll say that again, faster and more efficiently than what they would do themselves. Okay, now I'm going to talk about how AI fits in here, and when I say that, I don't intend to replace me with an AI. Okay, and we'll get into that and why that can't occur. All right, the whole idea of this is to give you warning. Okay, me being a reliability engineer, I'd like warning that our machine is about to break down. And the way sorber works is we can actually present that warning to an operator, or we can also present, hey, our process is now starting to deviate, please change something, and it'll advise you what to change. Now that's in real time, and we can do it as the picture shows there on the screen for the operators to actually respond to. Okay. What I would like to do now is go into why or how machine learning actually does this. Okay. And I've got a little simple diagram here. It's a little hand-drawn sketch by yours truly. Okay, so how machine learning works. If you present the two data streams to our sawbots, okay, I'm talking about, let me grab my little pen here. So we've got two data streams, 1 and 2, and they are simply sine waves, rightio? So they're simply sine waves. Not very good drawings, but okay. And what we've done is taught the sawbot what is normal, i.e. a normal sine wave. And he'll say that one's okay. All right, that one's okay. It's behaving like a sine wave. All right. However, he will tell you this one's not okay because we've got these little pimply, red pimply things happening here. And he will also tell you not only it's not okay, but where the problem is. Okay, because he's recognizing that difference in the pattern. He's really good at recognizing those subtle differences in behavior, i.e. this sine wave has a little pimple on it. Now, purposely, I've drawn it so that you can see how this works, but he is really, really good at finding those subtle behaviors or subtle changes in behaviors, to the point where I have done this stuff myself and compared and looked at what the sawbots picked up on. And if I was looking at it as it was streaming past me, I wouldn't pick it up. There's just too much happening, okay? There's just too much happening. Now, you'll note down here, this little guy can handle 1,000+ tags at the same time. I can't do that. I wouldn't have a chance. I wouldn't be able to even physically get it on the screen. But this is what this guy can do. And just to give you an idea of investment, in that it's about $20 a month to have one of these little guys doing that work for you, looking for those differences in behavior. Okay. All right. So me being a reliability engineer, okay, is an example. At a steel manufacturing plant, they're having compactor issues, okay? And what was happening was that the wire pressure cylinders and the wire compactors, all right, were consistently failing, causing compression speed and binding of the steel coils, right now. The problem actually occurred at the final stage of production, and they had to hold the whole production line, which is bad, okay? And what was happening was that the asset was unequipped with sensors to produce operational data, limiting the ability to predict and prevent failures. So what we did was we used the data that they did have, and I'm going to talk about this a little bit later because it's one of the fears. So we used the data that they did have using our little sawbot for $20 a month, and he started seeing the problems with up to 19 days of lead time because he's seeing that subtle difference in behavior in the data. Okay. Please feel free if there's any questions to give me a yell on the thing. But can I get a thumbs up from everyone that they've got what I'm talking about? Seen some examples here, see the advantages of the machine learning. Thanks, guys. Awesome. I can see the thumbs coming up here on the screen. And that's what this is all about, is to give you a bit of an introduction to how this stuff works and what you can achieve with it. Awesome. Thank you. Now, if you want to know if sawbots will work on your machines, there is a QR code. Please use your phone. We'll send a link out in a follow-up email as well. Please book me in. We are happy to discuss your problems, problems with your plant, not personal problems, okay, problems with your plant, and work a way forward on how we could help you solve those problems using machine learning. So please, you've now know how to contact me, please do so. I've got people ringing me saying, hey, Seven, I've got this problem. What do you think? And that's what I'm here for. All right. Now that we know how this AI stuff, or have a feeling on how AI works, obviously I'm not going to turn you an expert into an hour. What's some common fears and misconceptions about it? Okay. And the common one that you see on the interwebs and stuff like this, and it was very common in news and whatnot, is job displacement. All right, I'll just come straight out with it. People think that the AI is going to take their jobs. Well, as I sort of alluded to there before, people, AI augments human capabilities rather than replaces them. Okay. I used a simple example there where AI can enhance human productivity and handle the mundane tasks, i.e. going through 1,000 data points of information, okay, right? So I can farm that job out to the AI. It finds the problems for me in the data. I have a look at it and I go, oh, yes, there is a problem. Okay, so I've just saved all of that time doing what we call, I've even got a term for it, it's called data dogging, all right, and allows me to start problem solving the problem. Okay, so in other words, RCAing the problem, or habit 2 in my book, or start to understand what the problem is. Okay, so the AI is really good at diagnosing differences in behavior and pointing out the actual streams of data that are behaving differently. Okay. In its first pass, it may not recognize, hey, a specific failure mode. Okay, that's a bearing failing. But if you teach it after that, i.e. the human, that's a bearing failing. Okay, then we can teach it to recognize it ongoing. All right, so we can hard code those lessons that we've learned. Again, but it's me, the human, actually doing that. So what we have found, this exactly happens when people get their hands on Sorba. They realize that all of this weight comes off their shoulders because they don't have to do all the data analysis anymore. It's automatic for you. And the Sorbots recognize those subtle differences in behavior that gives them time, warning time, to actually respond. And in that response, they can actually drill down into the data because it's there on the system really, really quickly and go, oh, yes, our friendly Sorbot's got it wrong. Got it right. There is something going wrong. All right. So, yeah, that's exactly what we found is that once people wrap their heads around what the Sorbots can do, is that they then start using them to their advantage and they do the higher level tasks, i.e. problem solving, working on strategies, implementing solutions. The AI cannot change anything physical. Only humans can do that. All right. So keep that in mind, right? We know from our customers that Sorba augments your human resource capability on site, gives them more arms and legs to do more because they're not having to do the data dogging. Does everyone understand that? Can you give me the thumbs up on that? I think I've got a question too. Okay. Somebody's just asked, I can't see the name here, it just says attendee and not clear on what exactly they were checking on the coil. They were actually checking, there was actually a cylinder failing on the machine that produces the coil. Okay, so what we did was we took that data yeah, got it, thank you, to see that those cylinders are failing. But when those cylinders did fail, it basically stops the production process. All right. Yeah, I'm not sure if it was cylinder snap though. We'll find out. All right. The next slide there, people, or the next fear is high implementation costs. You've already got a feel for how much our little Sorbots cost inside Sorba. Okay. Long-term ROI, return on investment, outweighs initial investments. Okay, we actually have seen people get return on investment of their Sorba of less than 12 months, right? And the way that we like to do this, which, you know, we like to start out small, i.e. pilot projects, okay? You've got some numbers there on the screen. You know how much the Sorbots cost. Sorba itself can be installed for, now this is Australian dollars, by the way, not US dollars. This is Australian dollars for less than $2,000 per year. We can do also an AI as a service. So what that means is that if you do not have the skills, i.e. the people don't understand how to do this stuff or haven't been exposed to this stuff, and that's part of my role in the company, as you could probably guess here, is to bring people along on the journey from start to finish. Okay, I'm not a technical person, I'm a reliability engineer, I'm not a data scientist. Okay, so I jump in here at the start as a service and, you know, help staff get along with this technology, as it is awesome. Okay, and we can do that as a service, right? So we can help you out with this and bring the team along on the journey. All right, has everyone got that? So our advice is start out small. You do not need to spend a lot of money to dip your toe in the water to begin with this technology. Can everyone see that? The thumbs up. Excellent. Thanks, team. Awesome. Righto. Now, number 3, technical failures and reliability of the system. All right. We've got a team of developers developing the software that's rigorously tested, and they're data scientists, okay? And we are continually improving it. As a minimum, we release a new version every year. We improve the software. But you'll notice there, I've put here by the users as well. What does that mean? That's why I put the little smiley face here on the screen. Now, this particular screen here is what we call the machine learning trainer. Okay, remember that I was saying that the humans oversee this. What you can do, or what I can do as a reliability engineer, okay, is actually take some data and run it past the machine learning to see what happens. I can run past any data that I choose. Why? Because I want to be confident that the system is going to get it right. Now, I can do that offline. I do not have to do this in real time. We call it the machine learning trainer. I personally call it the dojo. I can put any data that I choose into this offline system, okay, and I can test it. I can test it. And then if we were looking at a critical system, okay, and we wanted to optimize the process, but we're not, we're dipping our toe in the water. This is the first time we've done it. We can also use the machine learning as an advisor. In other words, it doesn't directly control the process. It's advising us what it thinks you should do so that you can get confident that the system is reliable. All right. You see that strategy there, everyone? Can you give me the thumbs up? We do it a little bit differently to others in that we've got this thing called the machine learning trainer. You can throw your data in there and get confident that this is going to work. And then, thanks everyone, I see the thumbs up coming up on my screen there. And also, if it is like a critical system, we're not 100% sure that we want an AI to drive our process, our billion-dollar machine, okay? We implement that AI as an advisor to see if it's going to get it right, and we get confidence that it is going to get it right, okay? Thanks, everyone. I'll move on. Number 4, we find is data security, okay? We've got robust security measures inside Sorba AI, okay? We do realize that the data that potentially arrives in our system is operationally sensitive, okay, in many ways, and we basically employ basic-level security inside Sorba. And so, we just do not let anyone into the system, all right? We integrate things with Active Directory as well. And now I've just looked across and I see there is a question here. What is the data interface between your application and historian or live data? Is it via MQTT? Can I take that as a question on notice? Because I'm going to talk about that specifically in a slide. The answer is all of the above. We do things a little uniquely here at Sorba because of our system integration background. So I'm not going to go too much. I'll take that as a question on notice, and thanks very much for the question there. All right. So basically, to tell you a little bit of story around data security, one of our customers here in Australia have been, and talking about IoT devices and MQTT, one of our customers here in Australia, which is like a government-owned corporation, they have some rigorous security requirements around their data, especially if it's operational data as well. They've been exploring different devices. So they've been exploring these IoT devices, and that's where MQTT is a common way that IoT devices talk, for those that don't know. Basically, we've had suppliers with devices actually not able to land data inside Sorba because they could not comply with the security requirements. Okay, their devices are so lightweight that we had to use an intermediary service, i.e. like their own cloud service, and use an API to get the data in, where Sorba is actually pulling the data in rather than data being actually pushed to Sorba. Okay, so that's one little story there about data security. All right, we can lock this thing down as hard as you need it to be, and we've already got, for those in Australia here, we're already compliant to essentially Australian government rules around this. All right, everyone got that one? Give me a thumbs up. Thanks, team. Love it when the thumbs up come up on the screen. It comes up on my screen and it's a little animation on this end. All right, the next one is loss of human control. All right, Sorba operates under human supervision and control. I've already spoken about that. All of the algorithms are initially created by humans in Sorba.ai. All right, all of the algorithms are initially created by humans. There is no automated process to create an algorithm from scratch. There is an automated process, as I've alluded to actually improve the algorithms, where the system will actually retrain things automatically to get better. Yes, and it will tell you when that occurs. Okay, Sorba is designed to use by subject matter experts. I'm a reliability engineer. I specialize in that. I can use the system. Okay. Yandi, who is our Chief Information Officer, has a PhD in how to make machine learning easy to use. I can do it, all right? And I'm not a coder by any means, all right? And you can do it with no code. So here in Australia, we've had tradesmen or craftsmen, just to interpret, use the system successfully to create their own algorithms to look for things that they need to look for, okay? You do not need to be a data scientist to successfully use Sorba. It is written by data scientists and it's got all the data sciencey tools in there, like a Python scripting engine. However, you do not need to be a data scientist to successfully use Sorba. People like me, as in a reliability engineer or craftsman or tradesman, have successfully used it. All right, got the thumbs up on that? Has everyone got that? All right, you control the system as the human. Okay, awesome. Resistance to change. Okay, fact. We have found this, and you know, it's a subject that's, as a manager, I've been there, I've managed staff, and resistance to change is always a thing that you've got to work through. You know, it's that. You know, I call it a bulldozer. It's a thing that pushes back against you when you're trying to initiate something new. Now, this is new for some people, okay? I realize that, okay? And what we've found that works really, really well is hands-on strategies. The system is easy to use, all right? It is 4 clicks of a mouse to create an algorithm once the data is inside Sorba. All right. So it's not hard to use. And once people see the benefit, and I've seen this, I've seen people have aha moments with Sorba and they love it, right? They may not, they be maybe a little bit skeptical about it at the start because obviously it can do a lot of stuff as we've seen and can provide a lot of benefits. So people are naturally skeptical, okay? But once they get hands-on with regards to that, they love it. All right. We've had people where they've changed jobs and they've asked for it. All right. There's an example of how it's worked. So we've had people that work for one company move to another company and they've said, you need to look at this sort of thing. Like it is generally easy to use. We've got a few webinars on the Sorba University, so you can actually see some of this. And the Sorba University itself, sorry, I'm talking about this one down here. The Sorba University itself goes through how to set up things in Sorba, okay? We created the Sorba University to make it easy for people to start learning this technology. We can give you an educational version of Sorba so you can start learning it. That's complimentary. We do not charge for that, okay? So you can actually get some hands-on in the system and start seeing how easy it is to use. Now, we also offer expert guidance. I'm one of those people on staff, being a reliability engineer, to help your maintenance and reliability team with the predictive maintenance part of the software. So how to apply this in a predictive maintenance sense. I'm a vibration analyst, I've done oil analysis and all that sort of stuff as a part of my role as a reliability engineer over 15 plus years. So I'm one of the people on team inside Sorba to help guide your users and in fact help them coach, mentor, guide them through to success. All right, so there's some of the things that we do inside Sorba, maybe a little bit different to other companies to help people along the journey, especially in the industrial sense. Everyone got that one? Give me a thumbs up, please. Awesome. Thank you, team. All right. We like the hands-on part of this. You know, data is a communication of physically what's happening. All right. And we like to see those physical changes inside the data, and the Sorbots are really good at finding that sort of stuff. Okay, data quality problems. I've lost count of how many times this has occurred to us. Okay, the fear is that you need high quality data. It's absolutely critical, okay, for this to succeed, and we don't have it. We haven't got that data. Like I've got that. Or I get the data is crap. Okay, that's the other one that I get. The reality is you will be really surprised what you find in your existing data. That's why we offer the proof of concept. Okay, we take your existing data, run it through Sorba, and see what you actually get. Righto? Now, to do this sort of work and to test it, say you've got access to Sorba and you wanted to try something out new, we are talking about 15 minutes to half an hour from go to woe. Okay, to give you a little bit of time frame there. All right, so what we recommend you do is you start with what you have and improve over time. Okay, we've had a customer successfully predicted failures on railway switching points using only one data stream, which was amperage. Okay, there's some tricks to the trade of that, which we're happy to help you, guide you through that, but they only had one piece of data on that particular point. All right, so please understand data quality, start with what you've got, go from there, and 9 times out of 10, you're going to be pleasantly surprised. Has everyone got that one? Give me the thumbs up on that, please. Thanks, team. Awesome. All right. And truly, honestly, you will be pleasantly surprised. You'll be amazed with some of the stuff that we've found with these tools. okay, just using the existing data. Now, to come back to our question, okay, scalability challenges. Okay, Sorba is designed to be scaled. We actually use the same technology as Google does. Okay, and it's in the name. That's why I like the name Big Data Analytics. Okay, so it's got the horsepower, okay, and to actually be able to do the work that you need, okay, and where we find people get limited to scale, it's not necessarily us or the software, okay. What we find the main cause is around data access due to legacy systems or data silos. Okay, so what do I mean by legacy systems? Legacy systems are older systems that may not be compatible with new technologies like MQTT from the question that we had there earlier. Okay, all right. So, and with data silos, and we've experienced this and our customers have experienced this. Obviously, when you've got a critical plant being controlled by a computer per se, they will put a number of things in there to make it unhackable, okay, from a security point of view, all right? We've had one manufacturer of some control equipment say that their data or their system is unhackable, okay, and because we can actually custom build drivers that directly connect to the controllers themselves, okay, and I'm starting to answer that question from that's on the questions there, okay, so we can actually interface into the controllers themselves, the PLCs. I use that analogy there, but coming back to the original story, the OEM of this system said that the system is unhackable. We've designed it that way, and cut a long story short, we have some technical experts on our team and they had it in 6 weeks. Okay, so we had data flowing out of that unhackable system in 6 weeks, and that's from scratch with no documentation. Okay, that sort of tells you about our technical background, that Sorba, and there's no secrets here, the background company to Sorba, ITG, is a system integrator, okay? They work at this sort of level, PLCs, SCADA, and historians. So coming back to that question, all right? So I call this the older way of doing things, okay, where we can interface into the controllers, the SCADA systems, the historians like OSI Pi. And we can also interface into modern ways of doing things, i.e. MQTT and APIs as a couple of examples, okay? The system is designed to move data around from one system to another, and if you get onto the university, what I'm talking about there is what we call IoT connectors. There's a whole functionality inside the system that allows you to move data from one system to another without having to store it inside Sorba, okay? I'll say that again. We call it IoT connectors. There's a system inside Sorba that allows you to move data from one system to another without having to store it inside Sorba. Okay, so there's a whole heap of scalability tools that we've got in there. And of course, we can ingest that data and do processing on that data before it actually gets moved to the other system or stored inside Sorba. We can do that in real time, or we can do that as in the same style as a historian. In fact, Sorba has its own historian built in. So if you don't have a historian, which we've got some customers saying that to us, does it actually store data like a historian? Yes. Does it behave like alarms, like a SCADA system? Yes. All of the above. So hopefully that goes down the path of answering the question by the attendee there on the screen. If you give me a thumbs up, that you understand that basically inbuilt into Sorba, there's a whole heap of ways to get data into it or through it or pass it from one system to another, whether that's interfacing into the PLC, the SCADA system, or the historian, or pulling things off the internet. We don't really care, okay? Where the data is located, we'll go and get it, okay? the beauty of this is that you can then obviously pass it past the sawbots to see if there's any difference in behavior. So again, I use that as a reliability engineer to do predictive analytics. All right, so that's the 8 things that I wanted to go through. And now what we find is that the real benefits. Okay, so hopefully I've got an hour, right? I can't go into everything, and I've got all these examples that I'd like to show, and I'd love you to, get onto the university and have a look at how people have applied it. Jump on our website. There's a number of case studies there. We're going to give you some links to some as a part of a follow-up email. But what we're seeing is enhanced efficiency and productivity, removing that data dogging that I talked about. Next one, predictive maintenance. That's me. All right, being a reliability engineer. It's really, really good at seeing those differences in behaviour. So that's what our little sawbots there. Cost reduction and sustainability. We saw the example with the beer, 500 litres less of the filtering medium by using one of the sawbots to help control the process. Okay. Real-time monitoring. Okay, it can do this in real time. The system's got the capability. We use big data for this. We can, we can take things in via the millisecond and do stuff on it. All right. Now, increased safety. A little bit of a byproduct of this. We don't talk about this a lot, but if you've got, we've had it here before where a human is operating a process. Okay, the human is operating a process, and and I know that we make mistakes. One of the things that we've found with Sorba is that we've actually seen or got warning of humans starting to make mistakes, and the little sawbots actually pick it up before the effect actually occurs. Okay, so we've had that too with our customer base, where humans operating things, they've got the sawbots just looking over it, just making sure that everything's happening, and the sawbots are picking up on where the humans are starting to make mistakes. Okay, and of course they can then start alerting to that. Does everyone see that? Everyone see how we can actually apply it in a safety sense as well, which is pretty cool. All right, because obviously we want people to go home every day. Can you give me the thumbs up on that? Obviously, it's a segue. It's a segue to competitive advantage. Okay, we've seen our customers. Well, you've seen some examples here today from our customers where they're starting to, reduce the number of resources they need. They're starting to pick things early on their machines, and obviously, the holy grail of doing all of this stuff is to get competitive advantage, and and that's what we like to help people do. Okay, bring them along on the journey to find that competitive advantage. All right. So who's using Sorba? There's some brands there on the screen of who's using Sorba around the world here. And again, if you wanted to know more or see if the sawbots will actually work on your machines, that's how you do it. Please give me a call, contact me, book in with me now. The stuff that I've been showing you there today and the concepts I've been showing you there today start at $20 a month for our little sawbots in the predictive maintenance space, especially. All right. We've got the machine learning trainer there to help you along on the journey, get confidence that sawbots are actually doing the right thing. The interesting thing about the machine learning trainer is once you have Sorba installed, there is no limitation to the amount of analysis you can do in the machine learning trainer. Okay, so you can pull data from any other system that you so choose, import it into Sorba, run it through the machine learning trainer. All right. Is there any further questions before I announce the winner? Thank you for attending today. Our website is sorba.ai. Okay. Grab me if you've got any questions, or Peter said something about that today in the webinar. I'd like to ask him a question. Peter@sorba.ai, pretty simple email address. You'll find me. Find us on LinkedIn as well. And the university that I mentioned, we'll send you some links to the university as well. University.sorba.ai. Anyone can register for the university. You just need to go through a bit of an approval process, which usually takes overnight. So if you obviously sign in with a company email, not a Gmail or anything like that, we can give you access. Yeah, you've got my contact details there. If you want to talk about the tools, the process, or learn anything, please reach out. Here to help. Alrighty, everyone, that's it for today. Thank you very much for attending, and look forward to helping you on your Sorba journey. Thanks, everyone.